Let's take a look at number 15, structures. So when you build an app, you want to think about the kind of information that it needs. For example, if you're creating a shopping app, you're going to have things like products, shopping carts, customers, and orders. So what we're referring to is the data behind what the app uses, which is called the model or the data model. So the model or data model is unique to each app. For example, a music player would have tracks, artists, albums, playlists, things like that. Well, let's figure out how to create a model for an app. And first, we're going to start with modeling a song. Now we have different types. We've got string, int, double, and boolean. So how would we use that to represent a song or a list of songs? You could do something like this where you have an array of song titles, strings, you have an array of artists, durations, and then you put it together and it becomes a song by combining them like that. Now, the trouble is you're using an index across multiple arrays, and then it gets tricky, like how would you loop through everything? If you wanted just an array of songs, how would you get to that? And what if you added another property? How would you update that? Well, the way we want is to treat it as our own type. So we want a song type instead of just using strings and ints. So let's learn about custom types. The good news is we're not limited to the types that are built in. You can use existing types as a building block to make your own. So this is referred to as a structure or a struct. And it's a simple way of grouping things together. So a song would look something like this. You have struct is the keyword, song, and then you'd have title, artist, and duration. And then this would be treated as its own type. Now, this song has these different properties. It has title, artist, duration are properties. And then you can think of this as a group of three constants. Now, notice that when you create a new type, you use a capital letter. Property names are always lowercase, and that's the difference. That's how you know you're referencing a type versus a constant. So once you've created this like here, you would then reference it by saying song equals song, title, artist, duration. And so this is initializer for this type. So the initializer is automatically created for you, and it's basically a parameter of each member property. It's called member-wise initializer. All right, let's create a new song. And notice we get some auto completion, so we're going to say let song 2 equal song. And now we have the properties are already autocomplete for us, so let's go with title. We'll say where's my lunch by artist, food dude, and the duration is what, 90 seconds. All right, so there we've created a new song. Perfect. Let's take a look at struct properties. So we know how to access the properties, and it's similar to other types. We refer to it as the instance properties because this is the struct, which is a generic type, and then this is the instance. We've created song is an instance of type song. Well, if you want to reference each type, you can access it by doing dot title, dot artist, whatever those constants are. So when we look at this, let's take a look. The problem is you have properties that are of an instance. They're instance properties. When we are referring to our own custom structs, we're not referring to the title like the property on the song. So for example, if we uncomment this, what they're saying is the error says, hey, instance member title cannot be used on type song because this is an instance member property. So I want to comment that out again. Let's talk about mutability. So you remember when you use let, that means it's immutable where it doesn't change, or you declare with var, which is mutable. So an array is a kind of struct you can have, and it makes your own struct mutable or immutable. So to make properties mutable, there's two things. First, in the definition, you declare any changeable property as a var, and then you assign the struct to a variable, not a constant. Let me explain what that means. Here is our song struct, and notice that rating is a variable. Now, in order to make this work, you have to, your constant or variable you have to use a variable properly. In other words, if you change this to let, notice what happens. You're going to get an error because it's saying rating is mutable, meaning it's changeable, but if you set it as a let constant, then it's going to fail, so it's automatically changing. So that's the requirement. All right, so what we want to do is to talk about calculated properties. Let's look at the next one. So song has a duration which is in seconds, but it would be better if you could give the duration as a format of string which says minutes and seconds. So here you could have two properties, minutes and seconds, and then you'd end up with, you'd have to figure out, well, how many seconds or minutes is it when you assign that value. So another way is to do what we call a calculated property, and it looks like this. Here we have a variable formatted duration, and then within the curly brackets we have a calculation that takes care of it and returns this string. So now when we call this, we create a variable, constant song title artist duration, then we say song.formatted duration. So as you can see, it shows up 2 minutes 30 seconds. Now we've seen calculated properties before with the count of an array, and a calculated property is declared as a variable because it could change based on the rest of what's in there. So notice when we reference in this code what they're saying here, formatted duration, the property duration is accessed without dot notation. Within the code of a struct, you can access its own properties directly by their names without using the dot. So here we're just saying duration because it's within the structure. All right, let's add another calculated property to song named formatted title, which gives you a string for the song above. The formatted title should be No 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 by Fizz. All right, so let's go in here and let's add a var, and we say formatted title, which is a string, and here we're going to say return, and the string is going to be, whoops, the title, and then we're going to say title by and artist. Okay, so now let's go here and say song.formatted title. And notice how it shows up. Cool. Now let's talk about functions within a structure. So you can use structures and pass them into a function. For example, if you have a rectangle which is width and height, you could then pass in is rectangle. You pass in a type of rectangle, and then use those calculations, and notice the properties are available to you. And then you could do something like this where you're comparing it. Now, this is one way where you have a function that you pass in the structure to, but the problem is it's a lot of code on one line. It makes it harder to understand. The function's available everywhere in the program, but you only really need it when you're dealing with rectangles. And it's hard to understand where is rectangle as a function. So next, let's talk about making functions part of the type. Instance methods. So we've talked about instance methods before. When you create your own type, you can also define an instance method. So they're similar to functions, but you put them in the body of the structure. So here we say structure rectangle has two properties, width and height, and then it has a instance method bigger than, and it takes a rectangle and then it does the calculations. So here again, notice we can access width and height. We don't need the dot notation. All right, so you can now call these methods on an instance. So here we've created two instances, one rectangle, other rectangle, and then we say rectangle dot bigger than other rectangle. See how that evaluates here. Okay, now they want us to simplify the bigger than method by creating a calculated property named area for the rectangle, and then use the calculated property inside bigger than. So when we do a calculated property, remember it is a variable. So we say var, we're going to say area, and it is an int. And then what we want is to calculate. We say width times, let calculated area equal width times height. So that's how you, and then we can say return calculated area. Okay, so now here we can update bigger than function and say we don't need to, we just say rectangle, we say area. We don't need this this constant because area 1 represents the current rectangle, which is the one we were in. So we don't need that. We can delete that. Then we can just say area, return area greater than area 2. In fact, we can change this because we now remove this and we just say, whoops, we say dot area. That's one way to do it. Now, here I'm creating a constant, then I'm returning that, and I'm creating a constant here and I'm returning that, or using it in the calculation. I could simplify this even more by just saying return width times height. But sometimes it's good to use a constant in the calculation so that you see what it is that you did, and it really doesn't have an impact. So you may try that and kind of get used to it. Otherwise, you can use shorthand. You can put it all in the return. I tend to prefer to see things written out so that if I have a mistake in a calculation, I can then, print the variable and see, print the property, the calculation, and see where it went wrong. All right, very good. Now let's see what we've talked about. We talked about every app has a data model. You can create your own types. You use one way to do that is defining a struct. And a struct is a type that can group together properties and methods. So you can use properties to hold data. You can use variables or constants, and others can calculate values. You can use these instances in your custom types as you would any other type. And you can use custom types, including function, parameters, and return types, All right, let's go on to the next exercise because there's only one exercise in this video. So let's take a look at it now. When we worked with the types playground, we had a chance to think about some real-world examples of types and the associated types they might depend on. So a training shoe, for example, might have size as well as, which is an int, and a brand name that's a string, and a release date that's a date. So think of another real-world object and its properties. Make up some actions and behaviors that the object might be able to perform. Write them in plain English first in a comment. So then use the struct syntax from this lesson. Create a type for your real-world object with properties and methods. Remember to mark each property with let or var depending on whether it should be changed. And then if you're not sure how to implement something in a method, just describe it in what it should do in a comment. So for example, if we go down here, this is an example where you have a placeholder, and here you have a shoelaces struct, but we don't have any properties for it. But then when we say training shoe, we say it's of type shoelace. We have laces of type shoelace. And then we have a function here, a couple of functions, but there's nothing implemented yet, but these are just comments. So that's one way to create a type. So let's create, I think I'm going to go with a pizza. So, and a pizza includes toppings as well as a size, which could be something like small, medium, or large, or family size. And what else on the pizza? How about we say delivery time? Okay, so we're going to go ahead and say struct pizza. Oops. Okay, now a pizza is going to have a variable of toppings because the toppings may change. And it's going to be an array of strings. Then we're going to have size, which is also a string. And then we're going to have delivery time, which is an int. Now, let's have a calculated property. We're going to say var time string, which is a string, and it's going to return, what is it? Let's go back. I'm just going to copy and paste the example. Okay, I may have skipped around a little bit. Let's find it. I want to show the source for this. If you go over here and you show the Navigator, calculated properties, that's what I wanted. Okay, this is what I want. I'm going to go ahead and copy that. Now I'm going to go back to mine, and I'm going to place it right here. Perfect. I got to update this, so we called it delivery time. Delivery time. Very good. All right. Now we're going to say let my pizza equal pizza, and toppings we're going to have a string pepperoni. I'll learn how to spell, I promise. Bacon and cheese. Okay, the size, we're going to say family size. And delivery time, hopefully, is going to be 30 minutes, which is 30 times 60 is 3,600. Okay. Now we're going to say my pizza dot time string. That's going to be 60 minutes. Awesome. All right, thank you for watching, and be sure to subscribe and look for the next video.